The moon isn't as quiet as we thought. When Apollo astronauts placed seismic sensors on the lunar surface, they discovered something amazing. Our moon rings like a bell, creating its own cosmic symphony of vibrations and tremors. Back in 1969, Apollo astronauts weren't just there to collect moon rocks and plant flags. They brought along special sensors called seismometers. Think of them as super-sensitive microphones for detecting vibrations. When they set these up on the moon's surface, something incredible happened. The instruments started picking up regular shakes and tremors that nobody expected to find. The moon, which everyone thought was just a quiet, dead rock, was actually alive with activity. These vibrations weren't random either. Some happened when meteorites hit the surface, while others came from deep within the moon itself. The most fascinating part: when something hit the moon's surface, the vibrations would continue for up to an hour, way longer than similar tremors on Earth. It was like the whole moon was ringing like a giant bell in space. Scientists have discovered 4 main types of moonquakes, each with its own unique pattern. Deep moonquakes happen about 700 kilometers below the surface when the moon's core shifts and moves. Then there are thermal quakes, which happen when the moon's surface heats up after 2 weeks of freezing darkness. These are like the moon's version of stretching after waking up. The third type occurs when meteors crash into the moon's surface. These impacts create waves that bounce around inside the moon like a ping-pong ball. Finally, there are shallow moonquakes that happen just 20-30 kilometers deep. These are actually the strongest type and can reach up to 5.5 on the Richter scale, strong enough to shake a lunar base if we built one. What makes these quakes extra special is how long they last. On Earth, quakes die down quickly, but on the moon, they can keep going for hours. The moon's unique way of handling vibrations is a lot like what happens when you tap a crystal glass. The sound keeps going and going. This happens because the moon's outer layer is made of really dry, broken-up rock that's been crushed by countless meteor impacts. Unlike Earth, which has water and soft soil to absorb shockwaves, the moon's dry, rocky surface acts like a perfect conductor for vibrations. When a meteorite hits or a deep moonquake occurs, these waves bounce around inside the moon almost freely, with very little to slow them down. The rocks actually work together like a massive network of natural speakers, passing the vibrations from one to another. This is why a moonquake that would last only a few minutes on Earth can continue for hours on the moon. It's as if the entire moon becomes one giant musical instrument, creating its own space symphony. Here's where things get really interesting. Scientists have found a way to turn these moonquakes into actual sounds we can hear. The seismic waves are too low frequency for human ears, so researchers use special software to speed them up about 1,000 times. When they do this, the moon's vibrations transform into eerie sounds, sometimes like wind chimes, other times like deep, haunting echoes. Each type of moonquake has its own unique voice. Deep quakes sound like distant thunder, while surface impacts create sharp, bell-like rings. These sounds give scientists valuable clues about what's happening inside the moon. They can tell the difference between a meteor strike and an internal quake just by listening to these converted signals, kind of like a doctor using a stethoscope to listen to a heartbeat. Deep moonquakes are one of the moon's most puzzling features, occurring about 700 kilometers beneath its surface. These quakes happen with surprising regularity, almost like clockwork, when the moon is at specific points in its orbit around Earth. Unlike Earth's earthquakes that happen randomly, these deep lunar tremors follow a predictable pattern, happening about once a month. Scientists believe these quakes are caused by the push and pull of Earth's gravity on the moon's deep interior. Think of it like squeezing a stress ball. As Earth's gravitational forces squeeze the moon, its deep rocks shift and grind against each other. While these quakes are usually small, they give us valuable information about the moon's core and what materials might be found in its deepest regions. Let's explore how Earth acts like a cosmic conductor, creating a monthly concert on the moon. Earth's gravity constantly pulls on the moon, similar to how the moon creates our ocean tides. This gravitational tug-of-war actually changes the moon's shape slightly, stretching it by about 6 inches. Think of it like gently squeezing a rubber ball. The moon gets a bit longer when it's closest to Earth and returns to normal when it's farther away. This regular stretching and squeezing is what causes many of those deep moonquakes we talked about. The moon's orbit isn't perfectly circular, so these gravitational forces change throughout the month. When the moon is closest to Earth, the pulling is stronger, leading to more quakes. Scientists have tracked these patterns and found that certain areas of the moon are more likely to shake when Earth's pull is strongest. Think of the moon's structure like a giant natural speaker system. The outer layer, called the crust, is made of broken, dry rocks that have been smashed by meteors over billions of years. Below this is the mantle, which is more solid but still allows vibrations to travel easily. Unlike Earth, which has water and soft ground to absorb shocks, the moon's dry, rigid structure lets vibrations travel with very little resistance. When a quake happens, the waves bounce between these layers, growing stronger as they combine. The moon's core might be partly melted, adding another twist to how these vibrations travel. This unique setup turns the moon into a natural amplifier. It's like the whole moon is one big echo chamber in space. When meteors crash into the moon, they create some of the most dramatic sounds in our lunar orchestra. These space rocks, some as small as a pebble and others as big as a car, slam into the moon's surface at speeds up to 50,000 miles per hour. Without an atmosphere to burn them up, they hit the surface with full force, sending shockwaves deep into the moon's interior. These impacts create a distinct pattern of vibrations. First, a sharp, powerful bang, followed by spreading ripples of energy that bounce around inside the moon. Scientists have recorded thousands of these impacts, and each one tells a story about the object that hit and what lies beneath the impact site. The really cool part is how these meteor hits help us map the moon's interior. It's like using a cosmic ultrasound to see what's inside our nearest neighbor in space. While the original Apollo seismic network stopped working in 1977, scientists haven't stopped listening to the moon. Today, they use advanced tools like laser ranging and satellite data to track lunar movements. Modern space agencies are planning to place new, more sensitive seismic stations on the moon. These new devices will be about 100 times more accurate than the Apollo-era equipment. China's Chang'e missions have already started gathering fresh seismic data from different parts of the moon. NASA's Artemis program plans to create a new network of sensors that will work together like a high-tech stethoscope, helping us better understand the moon's inner workings. These tools will be crucial for future lunar bases, as they'll help us predict and prepare for moonquakes. Understanding moonquakes isn't just about scientific curiosity. It's crucial for our future on the moon. When we build lunar bases, we'll need to know where and how strong these quakes can be. Think about building a house on Earth. You'd want to avoid fault lines, right? The same goes for the moon. Scientists are using seismic data to create safe zone maps, showing the best spots for future lunar colonies. They're also developing special building materials and designs that can handle the moon's unique shaking patterns. Since moonquakes can last for hours, structures need to be extra sturdy. The good news is that most lunar tremors are pretty mild, but we still need to plan for those rare, stronger ones that could reach 5.5 on the Richter scale. Thanks for joining us on this journey through the moon's mysterious vibrations. From deep quakes to meteor impacts, our lunar neighbor is more active than we imagined. If you enjoyed learning about space, hit like, subscribe, and share to explore more cosmic mysteries together.